reaction products questions. And before we start, you guys aren't responsible for naming mercaptans. I never taught you. So on your test, if this shows up, I'm changing that, all of these mercaptans to thiol. And then you know there's a SH on carbon 3. 3-heptane thiol means that. And thiol here too. So that would be a substitution reaction because there's your SH nucleophile, right? And the last one's got to be an elimination because I see an alkene in there. We got to figure out if that's relevant. So this is straight up analysis right here. We have R3-methyl, 3-bromo heptane. So it's tertiary. Let's prove it. And I'm just going to write R up here. You don't have to draw it. You just need to know it's R to start with. And we got a bromo and a methyl up there. Tertiary RX. I'm thinking SN1. Even though I've got strong nucleophile, saying SN2. Even though I got a polar A product saying SN2. You can't change your mind from a tertiary carbon and make it go SN2. They don't go SN2, ever. I don't have any strong base. I don't have any heat. So E2, that third product is ridiculous, okay? It's a minor product at best in an SN1, the third product. It's got an alkene in it. It's an elimination product.
So unless I don't know the first one, it's going to be whatever the first one says.
Yeah, if you don't have the student asked, if the first part's not an I don't know part, which would be secondary, then you know right away, unless there's an override. Remember the overrides are strong base and heat. I don't care what your RX is, you're doing E2. Yeah, or a bulky base without heat. With or without heat, a bulky base. And that's coming up on our next example, by the way, but let's not look ahead. So you're looking at SN1. What happens to a stereocenter in an SN1? 50-50 RS. So I'm looking at 1 and 2. 50-50. That's choice D. This one I'm not even going to do the analysis because this is one of the strong bulky bases. Strong base that's also bulky. Forget about analysis, it's E2. Done. Yeah, just find the one that's an alkene. Yeah. You'd also make some E3-methyl-2-heptene, but I didn't ask about that one because you could have gone the other direction. Major product after the sequence below. Step 1 is going to make this. And it's going to be OTS. Stays the same. The stereocenter stays the same because there's no backside attack in that one. So it's just still going to be R. So this is now a secondary RX. After step 1, you've made a secondary RX. Now do your analysis. I've got a strong nu. SN2. I got a polar A protic. This is exactly what the other student was asking about here. You have to use the nucleophile and solvent when you don't have a decision from the first part. So we're looking at an SN2 that puts an ether, an ethoxy group. Ethoxy group is going to be added to carbon 3. Backside attack, why? SN2. Backside attack on an R stereocenter Gibbs, S. So I like choice 2 only. Good stuff, huh? What are the products here? Oh, we're heating up And alcohol. Here's the alcohol. It's R. You heat it up, you're going to get two major products. You're going to get, remember, dehydration of alcohol, sulfuric acid and heat causes dehydration. You got to talk alpha and beta. You're going to get alpha beta to the left with trans being major, and alpha beta to the right with trans being major. Okay, so I like the E3 and the E2. This is 1. This is 2. No, this is 3. No, this is 2. And that will be minor, the Z. So like 1 and 2 equal amounts because they're both trans. They both have the same substitution. The alkenes each have 1 carbon on each side. So you can't use that to decide. You got to use the fact they're equal. And so 50-50, 1 and 2, and a minor 3. 1, 2 major, 3 minor. Good stuff. And we got a diol. It's going to be a pinnacle rearrangement. When we have a diol and we heat it up with sulfuric acid, it's got to be a vicinal diol. One, two, three, 4, 5, 6, 7. You're going to get cation. Which cation's better? Well, initially, this cation's better. I'm not doing the mechanism. I'm just highlights. And the other cation's not as nice. In fact, it's pretty bad. Don't forget, you got to do the rearrangement to make the cations better. You're going to move the H. And this one, you're also going to move an H. You got to move something away from the alcohol carbon. And you're going to get that, which becomes heptanal. After you take the H off. This one's going to go to this one. Need the cation where the O is. That's why we did the rearrangement. 2, 4, 6, 8. Sorry, too many carbons. And it's going to make 2 heptanone. But I like this cation a little better than this. I like them both a lot. They resonate with the O. That's the main reason this reaction is so easy. You're making cations that resonate with the O. But this one is a secondary resonator, and this one's a primary resonator. So I like secondary major to make 2 heptanone. Maj, 2 major, and 1 minor. You can't make 3 heptanone. You got to get a carbonyl where you used to have an O, and there was never an O on carbon 3. And so 2 major, 1 minor. There we go. And 1 heptene with the oxymercuration. This is where we're combining reactions. 2, 4, 6, 7. 1 and 2 do this. Markovnikov addition of OH. And then PCC oxidizes any alcohol to a carbonyl, except for tertiary. No reaction with tertiary. But primary, PCC makes aldehyde. Secondary, PCC makes ketone. PCC, no mechanism needed. You just need to know what PCC does. She asked, do we need to know the PCC mechanism? And we don't. So 2 heptanone only. Very good stuff. Good segment there.